Hi students, this is Mr. Yao. Today we are going to talk about 5.3 where we will learn how to solve a triangle. It's going to use the things we have learned already and add on a little bit extra. This video actually contains two lessons. The first lesson is 5.3a, which will end after example 7, and the rest will be 5.3b, which is the second lesson. Now let's get started. Solve a right triangle. It means to find all of the parts of a right triangle, including all three sides and all three angles. Well, a triangle only has three sides and three angles, so we're basically finding every single piece of information about a right triangle. That's called solving a triangle. Next, steps to find the missing side. We have actually learned how to do this already, so we're kind of just putting everything together now. First, locate the given angle and label all the sides with opposite, adjacent, or hypotenuse accordingly. You don't have to write the whole words, just use O, A, or H. And remember, we gotta start with the given angle, because based on the angle, depending on the angle, we're gonna change the opposite and adjacent based on the angle. So be very careful with that. Step 2, decide which sides are given. X is considered as given. You'll see what that means when we get to an example. Step 3, based on the size given, choose the right trig function to set up the ratio using SOLVATOA, then solve the equation. So let's have a look at some examples. First, identify which trigonometric ratio is needed to solve for the missing side, and then write the equation solve around to the nearest hundredths place. So example 1. 44 degrees right here, the 14 is facing it, so that's got to be our opposite, and x is going to be the hypotenuse. So in this case, we know it's opposite and hypotenuse involved, so we're going to use sine. And we're just going to use sine 44 degrees to set up the equation. It's opposite over hypotenuse, so it's going to be 14 over x. When x is on the bottom of the fraction, there's kind of no way we can solve it. So we are going to need to get x out of the denominator. So we're going to multiply both sides by the x. So we get x times sine 44 degrees equals to 14, because these two x cancel. And afterwards, we're just going to divide by sine 44 degrees on both sides. And that will give you x. And so we're going to type this whole thing into your calculator. And again, remember, whenever you type these trig ratios, make sure to check the mode first and make sure it is on degree in your calculator. Now, x is 14 over sine 44 degrees. Type in your calculator. That should give you 20.15 after rounding to the nearest hundredths place. That is example 1. Example 2. Angle is right here. That is going to be my opposite side, and this is my adjacent side. So if we have opposite and adjacent, that's going to be TOA, so we're going to use tangent. Tangent 61 degrees is opposite is x, adjacent is 16. Now x is actually in the numerator, so we just need to get rid of the 16. So multiply both sides by the 16. X equals 16 times tangent 61 degrees. Type in your calculator. That should give you 28.86. That is example 2. Next, example 3. Angle is right here. This is adjacent because it's next to the angle, not facing it. This will be the opposite. And the 11 is facing the right angle, so that is going to be the hypotenuse. So I'm using adjacent and hypotenuse for this example, so that is going to be cosine. So cosine 51 degrees equals to adjacent x over 11. X is on the top again, so we're just going to multiply both sides by 11. So x equals 11 times cosine 51 degrees. And that is going to give you 6.92. Hopefully now you understand what it means by we need to consider x as a given, because we're going to use x to set up the equation. So we are going to treat x as a known value so that we can set up the equation. Then we use the equation to solve for the x. Next, example 4. The angle is right here. That is my opposite side. So x is actually my adjacent. So I am involving opposite and adjacent. That is going to be tangent. Tangent 56 degrees is opposite, which is 11, over adjacent. Adjacent is x. So first, we are going to multiply both sides by the x. So x times tangent 56 degrees equals 11. Now I can divide both sides by the tangent 56 degrees. So x equals 11 over tangent 56 degrees. Type in your calculator. That should give you 7.42. That is example 4. Next, we are going to do something else. We are now going to know how to find the missing angle. The first part of the process is the same. You got to locate the desired angle. That's always the case. You have to locate the angle that we need so that you can label the opposite and adjacent and hypotenuse correctly based on the desired angle. After that, you're going to, based on the angle, choose the appropriate trig function to set up the ratio using SOHCAHTOA, and then solve the equation. Solve the equation. Now let's have a look at a few examples. Something to remember, we're solving for an angle, so that means we are going to need to use our inverse trig function. That is what inverse trig is used for, to find missing angles. So example 5, that is the angle labeled. 14.3 is next to it, so that's the adjacent. 19 is facing the right angle, so that's going to be the hypotenuse. So now let's set it up. It's adjacent and hypotenuse, that's going to be cosine. So cosine theta, or in this case cosine x, is 14.3 over 19. I would actually recommend you to not calculate out 14.3 over 19 yet, because if you get a decimal and you round 2 decimal places, then when you do the next step, you're going to round again. It's kind of getting further away from the correct answer. So let's actually not round it. We already know if we want to get into the x inside there, we are going to need to use the inverse function. So x is going to be cosine inverse, or arc cosine of 14.3 over 19. And that is what you are going to type in your calculator all together. That should give you 41.18 degrees. That's example 5. Example 6. X is right here, and that means 21 is the opposite, 7.6 is the adjacent. That means I need to use TOA. So tangent x is going to be 21 over 7.6. So that, after typing your, well, let's actually rewrite it first. Using inverse is going to be inverse tangent of 21 over 7.6. Typing your calculator, that should give you 70.10 degrees. That's example 6. Next, example 7. Ooh, this looks a bit more complicated, a bit tricky. It's asking you to find angle x, then y, then z. Well, then let's focus on angle x first. That means we need to look at this right triangle right here. With angle x, the 15 is the opposite and 30 is the adjacent. This is the opposite and that's the adjacent. So we can set up tangent x, which is 15 over 30. So that means my x is going to be inverse tangent of 15 over 30. That should give you 26.57 degrees. Next is asking you to find y. Y is right here. Well, this is the triangle is being involved, so we are now going to look at this bigger triangle right here for y. With y, this is going to be the opposite side, and this altogether is the adjacent side. So that's actually 25. But since it's opposite and adjacent again, we're going to use tangent. So tangent y is opposite is 30, adjacent is 10 and 15 together, which is 25. So y is going to be the inverse tangent of 30 over 25. That, after solving, should give you 50.19 degrees. Lastly, we are going to solve for z. You might be like, wait, but I don't have any right triangle for z. Yeah, we don't. However, we have just found y, x, and we already know that's a 90-degree angle. Something else you should remember, sum of a triangle should be 180 degrees. And I mean sum of the angles inside the triangle. I'm just writing it shorter. So that means I can actually get rid of this 90 degrees. That means all the other 3 angles should add up to 90 degrees. So z would have to be 90 degree minus x minus y. So 90 minus 26.57 minus 50.19 is going to give you 13.24 degrees. And that is our z. That's example 7. And that concludes 5.3a lesson. Now let's move on to 5.3b. Example 8. Solve for all missing parts of the triangle. All missing parts means 3 angles and 3 sides. We're going to need to find every single piece of information. So again, we're just finding missing sides and missing angle, which is what we just learned in the previous part of the lesson. So example 8. Well, this is the angle. With that 180-degree rule, we can easily find out this angle would have to be 53 degrees, because that's 90, 180 minus 37 minus 90 is going to be 53 degrees. Even though we have found that 53 degrees, we don't have to use the 53 degrees. We can still use the 37 degrees to set up our trig ratio. So let's say this is the opposite side, my adjacent side is the 14, and this is the hypotenuse. So now I need to find the opposite side. If I want to find the opposite side with the adjacent side given, I'm going to use tangent. So tangent 37 degrees is opposite over my adjacent is 14. So times 14 on both sides. My opposite side is 14 times tangent 37 degrees. That is going to give us 10.55. That's for opposite side. Now you can technically use the opposite side and adjacent side with Pythagorean theorem to find hypotenuse. However, this is a number that we have rounded already. If you use a rounded number, then find the answer round again. Again, it's going to be a bit more off than the correct answer. So my recommendation is always to try to use the number that's already given or is a pretty precise answer without rounding. So let's actually use the hypotenuse and 37 degrees with the adjacent. So this time we're using adjacent hypotenuse. That means it's going to be cosine. So cosine 37 degrees is going to give me adjacent over hypotenuse 14 over the h. So I'm going to multiply both sides by h, and so my 14, my h times cosine 37 degrees is going to be 14. Divide both sides by the cosine 37 degree. My h is going to be 14 over cosine 37 degrees, should give you 17.53. That should be my hypotenuse. That's example 8. We have found every single piece of information. Adjacent is given, we found the opposite, we found the hypotenuse, the angles, we already know everything. That's example 8. Next, example 9. Very similar to example 8, we are given an angle and a side. It's just this time the side that was given is the hypotenuse. So first, we already know that's 38 degrees, that's 90. So 180 minus 90 minus 38 will give us 52 degrees. Oh, the angles are very similar to example 8. So now I'm going to use the 38 degrees to find my opposite and my adjacent. So first, if I want to use opposite with the hypotenuse, I'm going to need my sine. So sine 38 degrees is going to be opposite, I don't know, over hypotenuse is 7.8. So opposite is going to be 7.8 times my sine 38 degrees. I'm just multiplying both sides by the 7.8. And that should give me 4.80 as my opposite. Next, for adjacent, I'm going to use adjacent hypotenuse, so my cosine. Cosine 38 degrees is my adjacent over hypotenuse, which is, I'm not going to write the h, is actually 7.8. So I'm going to multiply both sides by the 7.8, and adjacent is 7.8 times cosine 38 degrees. That is going to give me 6.15 as the adjacent. We now have every single piece of information. We have all the angles, we have hypotenuse, opposite, and adjacent. That is example 9. Next, example 10. This time, we already know two sides, but we don't know the third side. But since we already know two sides, and these are precise answers, we can use Pythagorean theorem to find the last side. So BC is going to be, well, be very careful. This is actually my hypotenuse. So I'm going to use BC as 21 squared minus 14 squared, because technically it's 14 squared plus BC squared actually equals to 21 squared. So I'm going to subtract that over. And this should give you 441 minus 196, which should give you 245 under square root. That is going to be 15.65 after rounding. That's BC. Next, I'm going to find an angle. Let's start with this angle. It doesn't quite matter which angle you want to use, but based on the angle you choose, of course, your opposite and adjacent is going to change. So I'm going to use this as my x. That means This is my opposite, that's my adjacent, and this is still my hypotenuse. Now, I'm not going to use the opposite side since that is a rounded answer, so I'm going to use adjacent and hypotenuse for my x. Cosine x is adjacent, which is 14, over hypotenuse, which is 21. And that is going to give me x equals inverse cosine of 14 over 21, which should be 41.81 degrees. And lastly, for b, well, you can also call this angle A. That's fine since that's letter A. For the other angle is going to be 180 degrees minus 90 degrees minus 41.81 degrees. That should give you 48.19 degrees. You can call this angle B. You can say this is actually angle A. That's typically how we write it. That's example 10. We found every single piece of information. We found the opposite. We found both angles. We are good for example 10. Next, example 11. Find the length of BC and AC. BC right here. Angle is right here, so that's opposite. This is adjacent, and that's hypotenuse. So basically asking you to find adjacent and hypotenuse. Let's set it up. With adjacent, and I already know opposite, I'm going to use tangent. So tangent 60 degrees is going to be my square root of 3 over my adjacent side, which is basically BC. I'm going to use BC, well, just because letter A, O, H, well, I already have letter A as one of the points, so I'm going to try to clarify with that. So I'm going to use just BC as the side. So multiply both sides by BC. I have BC times tangent 60 degrees equals square root of 3. So BC is going to be square root of 3 over tangent 60 degrees, which actually is going to be a 1. And that 1 is actually a very precise answer. So when I try to find my AC, I can either use opposite and hypotenuse using the sine, or I can just do Pythagorean theorem. 1 squared plus square root of 3 being squared. That's basically square root of 1 plus 3, so square root of 4, which is 2. So my hypotenuse is 2, my adjacent is 1. This is actually one of the special right triangles we will talk about in the next lesson. 60 degree is going to give us a 1, a square root of 3, and a 2. That kind of relationship. We will learn more in the next lesson. Example 12. 45 degrees. So that means this one have to be 45 degrees. It's asking you to find x and y. You can choose to, well, since this is the side we already know, if we're using this angle, that's going to be opposite and adjacent. So I can use tangent 45 degrees equals my opposite, which is my y over 4 square root of 3. So multiply both sides by 4 square root of 3. You're going to get y equals 4 square root of 3 times tangent 45 degrees. And you type in your calculator, that will give you 6.93 after rounding, which actually is 4 square root of 3. Because if you actually type in just the tangent 45 degrees, you will see that is actually a 1. And 45 degree is another special triangle we are going to learn in the next lesson. But for now, you can just kind of keep in mind. Next, if we already know that's 4 square root of 3, both of the sides, we can actually use Pythagorean theorem. But since we actually use a rounded answer, let's actually use the trig ratio to find my hypotenuse, which is my x. So let's set it up. Since we already have adjacent and hypotenuse, it's got to be cosine 45 degrees. That is the adjacent, which is 4 square root of 3 over my x. So I'm going to multiply both sides by the x, then divide both sides by the cosine 45 degrees. So my x is actually 4 square root of 3 over cosine 45 degrees. After rounding, that should give you 9.80, which actually is 4 square root of 6. So this side is actually 4 square root of 6, and that is 4 square root of 3. We will know these precise answers after we learn the next lesson, which is special right triangle. So that is example 12. Next, example 13. Find angle A, B, then C, and then is asking, is triangle ABC a right triangle? So let's find angle A first. Angle A. We have 7 and 5. That is the opposite side and the hypotenuse. So that means I'm going to use my sine. My sine A is actually going to be 5/7. So since I'm trying to solve for an angle, I'm going to use inverse trig. So my angle A is going to be the inverse sine of 5/7. And after you type in your calculator, that should give you 45.5847 degrees. I'm just gonna keep it a bit more since there might be some rounding going on. Next, finding my angle B. Angle B facing that, so that's still the opposite, and this is the hypotenuse. I'm going to use my sine again. Sine B is opposite, which is 5, over hypotenuse, which is 10. So I'm going to use my inverse sine again, but this time it's not 5 divided by 7, it's 5 divided by 10. So B is inverse sine of 5/10. That should give you 30 degrees. Exactly. So I already found my this is 30 degrees. I can easily find out 90 minus 30 is going to be 60 degrees right here. That is 60 degrees. Then I can easily find out the other one. 90 minus 45.58 degrees is going to be 44.42 degrees. So this is 44.42 degrees. And we can just check if that's actually 90 degrees. I'm going to actually change the color. 44.42 degrees plus 60 degrees is actually going to be 104.42 degrees. That is clearly not a right triangle, so not a right triangle. That's example 13. Now, after we have done everything in this lesson, we may have some conclusions that could help us. So here comes the next part. That's the next part. Situations in solving a right triangle. If you know two sides, think about it. If you already know two sides, that means you have a right triangle. You kind of know like the A and B, or like the A and C, whatever. It is a right triangle. You are going to use Pythagorean theorem to find the third side. If you know one acute angle, remember it's a right triangle. So that means you not only know an acute angle, you also know a 90-degree angle. So these together and the third angle is going to make up 180 degrees. So we're going to use 180 degrees to find the third angle. Next, if you know one angle and one side, well, you have one angle and one side. So basically, like for example, you know one angle and like one side, like the opposite side. Well, then you can use that if you are trying to find the adjacent, use tangent. If you're trying to find the hypotenuse, use sine. So that's why you're going to use the trig ratios to find the other side. When you're trying to find sides, you're going to use the trig ratio. Next, if you know 2 or 3 sides and you're trying to find the angle, of course, you are going to use inverse trig to find the angle. Now, these are the few conclusions that may help you to be a bit clearer on when to do what. And that is everything for both lessons in 5.3. Thank you.